Have you ever wondered how to calculate the circulation of a fluid around a closed path, or the voltage generated in an electric circuit, or the force on a charged particle moving through a magnetic field? Stokes' theorem, a fundamental theorem in vector calculus and differential geometry, can help. Stokes' theorem, also known as the generalized Stokes theorem, establishes a relationship between the line integral of a vector field around a closed curve and the surface integral of the curl of that vector field over a surface bounded by the curve. In layman's terms, it states that the circulation of a vector field around a closed curve equals the flux of its curl through any surface bounded by the curve. Mathematically, we express Stokes' theorem as follows. The line integral over a closed curve C of the vector field f dot dar equals the double integral over the surface S of the curl of f dot ds. In this equation, the symbols represent the following. C is a piecewise smooth closed curve in three-dimensional space. S is a piecewise smooth oriented surface bounded by C. F is a vector field in three-dimensional space. The dot denotes the dot product. The integral symbol denotes a line integral. The double integral symbol denotes a surface integral, and curl, F, denotes the curl of the vector field, F. Stokes' theorem has widespread applications in physics, engineering, and mathematics. It can calculate the circulation of a fluid around a closed path, the voltage generated in an electric circuit, the force on a charged particle moving through a magnetic field, the torque on a rotating body, and the work done by a conservative force field. To illustrate, consider a vector field fxyz equal to z squared, negative 3 times x times y, and x cubed times y cubed. To calculate the circulation of this field around the closed curve C, which is the boundary of the unit square in the xy plane with positive orientation, we apply Stokes' theorem. We convert the line integral into a surface integral over the surface S, which is the unit square itself, oriented with its outward normal vector pointing upwards. The curl of f is 3 times y squared, negative 3 times z squared, and negative 3 times x squared times y squared. Evaluating the surface integral over S, we find that the circulation of f around C equals 4. Now consider an electric circuit C with an electric field EXYZ equal to 2 times xy and negative 3 times z. Stokes' theorem relates the voltage generated in the circuit to the magnetic field induced by the circuit. If the electric field is constant, the time rate of change of the magnetic flux equals 0. Hence, the voltage generated in the circuit equals 0. To summarize, Stokes' theorem is a powerful tool in vector calculus and differential geometry, with a variety of applications in physics, engineering, and mathematics. It establishes a relationship between the line integral of a vector field around a closed curve and the surface integral of the curl of that vector field over a surface bounded by the curve.